My name is Nandini Gondali. I now am studying in a BSc second sem. My combination is CBZ. My college name is Sri Siddheshwara Government First Grade College, Nargund. My assignment topic name is Molecular Orbital Treatment of Mononuclear Diatomic Molecule. Molecular orbital treatment of mononuclear diatomic molecule O2. And with calculate and relationship between the bond length, bond order and bond energy and magnetic properties. Now, molecular orbital treatment of homonuclear diatomic molecule O2. The molecular orbital treatment of oxygen realizes a paramagnetic nature due to the two unpaired electrons in degenerated pi antibonding orbitals, leading to a bond order of 2 and bond length is 121 pm and bond energy is 498 kg per mole. Oxygen molecule now already knows the oxygen atomic number, that is 8, and electron configuration is 1s2, 2s2 and 2p 2x, 2p1y and 2pz1. Each oxygen atom has 8 electrons, therefore there are 16 in oxygen molecules. Due to the combination of the atomic orbitals of the two oxygen atoms, then molecular orbitals are formed. These are filled in the increasing order of their energy according to the alpha principle. You already learned alpha principle in your first semester. Molecular orbital configuration of oxygen molecule. Oxygen atom has 2s and 2p atomic orbitals. In the oxygen molecules, these atomic orbitals combine to form molecular orbital, that is sigma and pi. Molecular orbitals, sigma and pi orbitals. Sigma orbitals in the oxygen molecules, that are sigma 2s, sigma star 2s and sigma 2pz and sigma star 2pz, and pi orbitals in the oxygen molecule, pi 2px, pi star 2px and pi 2py and pi star 2py. Electron filling. How do electron fill in the oxygen molecular orbitals? The 12 electrons from the two oxygen atoms fill the molecular orbitals according to the alpha principle and Hund's rule. The molecular configuration of the oxygen molecules is sigma 1s square, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2pz2, sigma 2px2 is equal to sigma 2py2, sigma star 2px is equal to sigma star 2py1. Here this is the molecular orbital energy level diagram of oxygen molecule. This is always in the increasing order. The electrons are filling. To construct a molecular orbital diagram for oxygen, we have to consider the interaction between both the 2s and 2p atomic orbitals on each oxygen atom. Because of the oxygen's high effective nuclear charge and the penetration of the 2s orbitals, there is a large energy difference between the 2s and 2p atomic orbitals. Now I will discussing about the bond order, bond energy, bond length and magnetic properties. First one, bond order. Definition. What is bond order? Bond order is calculated by a number of bonding electrons minus number of anti-bonding electrons divided by 2. Oxygen bond order is 2. For oxygen, there are 10 bonding electrons and 6 anti-bonding electrons, resulting into the bond order. The number of bonding electron is T and minus number of anti-bonding electrons is 6 divided by 2. 4 divided by 2 is 2. The bond order is 2. Implication. A bond order of 2 indicates a double bond which is weaker than a triple bond. but stronger than the single bond. The bond length is the average distance between the nuclei of two bonded atoms. Oxygen bond length is 121 pm, and relation with the bond order, compared with the bond order, higher bond order generally correspond to the shorter bond length, as the atoms are held closer to by the stronger bond. And now bond energy is 498 kg per mole. Bond energy is bond energy is amount of energy required to break a specific bond in a molecule. Oxygen bond energy is 498 kg per mole. Relation with the bond order. Higher bond order generally corresponds to the higher bond energy, as the stronger bond required to more energy to break a bond. Finally, magnetic properties. The oxygen molecule is a paramagnetism in nature because of two electrons in the pi star 2px and pi star 2py orbitals are unpaired and have a same spin. And it is applicable by the Hund's rule. The electron occupy the degenerated pi star 2px and pi star 2py orbitals individually before pairing off, leading to two unpaired electrons. Hence, there is a double bond in oxygen molecule. Due to the presence of the two unpaired electrons, it is a paramagnetic. And then thank you.